Hi everyone, I'm Jessica Guan and I'm a PM on the Azure Kubernetes Service on-premises team. Thanks for joining this session where I'll be talking about Azure Kubernetes Service on Azure Stack HCI. We've got some really great demos coming up that will show you how to seamlessly manage your on-prem Kubernetes clusters post-deployment. But first, if you want to try AKS on Azure Stack HCI and follow along the demos yourself, here are some helpful links. We've documented step-by-step tutorials of everything that is covered in this session so that you can test it out in your environment as well. So, what is AKS on Azure Stack HCI? Before we jump into it, let's take a step back. Before Azure Kubernetes Service on Azure Stack HCI, there was Azure Kubernetes Service, or simply AKS. AKS has been in market for a while now, and it's Microsoft's Kubernetes platform that allows you to run your containerized applications in Azure. These are some of the key benefits. AKS uses the existing Kubernetes technologies and applies them to Azure Cloud. You get the best practices and recommendations from all the learnings of Microsoft engineers building AKS, tons of engagement with enterprise organizations, and deep integration with the open source community. Security is another key benefit of AKS. It has multiple layers of hardened security and layers of isolation. In addition to that, it is fully supported by Microsoft, so that diagnostics and troubleshooting is fast and streamlined. Lastly, AKS also provides a unified management experience where you can manage your AKS resources and non-Azure-based Kubernetes resources all in one portal to make it an easy and seamless experience. So that brings us back to the original question. What exactly is AKS on Azure Stack HCI? Well, the name might be a spoiler, but it's AKS that runs on Azure Stack HCI. We're taking all the technology capabilities of AKS and giving you the ability to run it in your own data center on top of Azure Stack HCI. Because unfortunately, not all applications are created equally, and some can't run in Azure for whatever business reasons you may have, whether it be latency to the cloud or the need to have a fully disconnected production environment. But luckily for all those applications out there, Microsoft is an equal opportunity employer, so we still have a place for them. AKS on Azure Stack HCI is an Azure hybrid solution that allows you to run your Azure workloads on premises while still having the benefits of being integrated with Azure services. You can take those same Linux and Windows applications you have running in Azure and run them in your own data center without a whole lot of engineering work to change your application for compatibility or concern for losing the security that AKS provides. AKS on Azure Stack HCI brings you AKS consistency so that if you're familiar with AKS, you don't have to learn a completely new technology to start running your workloads on-prem today. Now, we've thrown around the word hybrid a few times by now, but how is AKS on Azure Stack HCI really hybrid? Well, hybrid doesn't just describe today's workplace, because AKS on Azure Stack HCI is hybrid by design, and it starts with Azure Arc. Azure Arc provides you a single control plane to standardize visibility, operations, and compliance across a wide range of resources and locations. Right from Azure, you can easily organize, govern, and secure Windows, Linux, SQL Server, and Kubernetes clusters across data centers, edge, and multi-cloud. Enabled by Azure Arc, you can bring Azure services to any existing infrastructure, including other clouds you are using. So you can take advantage of cloud benefits everywhere, such as scalability, fast deployment, and always up-to-date cloud innovation. You can build Azure consistent cloud infrastructure in your own data center with Azure Stack, so you can modernize your data center and run cloud-native applications on premises while taking advantage of existing investments and meeting regulatory compliances. You can extend AI to edge devices with Azure IoT, so you can run machine learning and advanced analytics close to the users and the data. As a result, you can gain real-time insights and deliver immersive experiences at the edge of your network, opening up endless new business opportunities. When you use Arc-enabled GitOps to deploy containerized applications on AKS on Azure Stack HCI, Git is your single source of truth. All actions taken by developers and admins on your AKS on Azure Stack HCI cluster happens in Git, and all changes are visible to project teams and can be tracked. Let's go over to Matt McSpirit, who will show us how easy it is to set up GitOps with AKS on Azure Stack HCI and how it takes seconds to go from code change to code deployment.
So what we have on the screen here is Windows Admin Center, and what it shows is a previously deployed AKS HCI target cluster for running our applications and workloads. And as part of that deployment process, we've automatically integrated this target cluster with Azure Arc enabled Kubernetes. So if we navigate over to the Azure portal, which I've got open here, you can see that we can start to integrate with new monitoring capabilities, very useful for monitoring our containerized applications. But in addition to that, we can also start to integrate with other tools and capabilities provided by the Arc-enabled Kubernetes, including Azure Policy for ensuring compliance in our environment, but more specifically for this demonstration, integration with GitOps, which allows us to start to automate deployments of applications down to our target AKS HCI clusters from a centralized Git repository source. So if we dive into that in a little bit more depth, what you can see here is we have the option to add a configuration that we can apply to this particular AKS HCI cluster. Now I can define this configuration either programmatically using Azure CLI, which is useful if I'm performing this configuration against a number of AKS HCI target clusters. But I can also have the option to create the configuration using the Azure portal, the familiar Azure portal. All I need to provide is a number of key pieces of information relating to our target cluster. And in addition to that, provide the repository that will contain our application data, our code that our development teams are working on. And this can be a private Git repo somewhere in our environment or available externally, or it can be a public repo on something like GitHub. Either way, you've got choices and flexibility. Now, in order to save time, here's one I've defined earlier, and you can see that I've applied that configuration already. It's considered installed in terms of its current state. But if we look at the details of this particular configuration that will apply to this AKS HCI cluster, you'll see that it captures the information about my AKS HCI cluster. The parameters that are important here include how frequently we're going to be polling the Git repo, that in my case is on a public GitHub repository, so no private repo in use here, but it's polling that particular Git repo every 3 seconds, which is a little bit aggressive but useful for demos. It's polling every 3 seconds to determine have there been any changes, have there been any new code been checked in by our development teams into that centralized Git repo. And in this case, it's going to pull from the Git repo that's listed here as well. And again, that's a public repo. So once those characteristics are defined, GitOps will automatically install the necessary components on our target AKS HCI cluster. So if we navigate over to that environment, what I'm going to do to show this is fire up a few different windows here. First, I'm going to navigate to the web application itself, and you'll see this is available on this particular IP address. Quite a basic application, but does a good job of illustrating this particular web app running across a number of pods within our AKS HCI environment, and we'll see that in a minute. And what you see here is I've set this refresh interval with this extension to automatically refresh the page every 2 seconds, and that cycles through the pods that are powering this application. If I open up my GitHub repo here, where the application code is being pulled from, you'll see that we've got all the necessary information. I'm looking at the main YAML file here, which defines the application. And as we scroll down, you'll see here's the key piece of code that we're going to make a change to in this, this demonstration. What you'll see here is the code here, the value matches what's on the right-hand side of the screen here. That is what's displayed in that banner. And we're going to make a change to that in a moment. But before we do, I'm going to fire up this PowerShell window and just set a watch command to check what's happening with the pods. And you'll see there are 3 pods powering this Hello Arc application. And the pod names in PowerShell here show and match those on the right that have been cycled through every time the page refreshes. So let's make a slight change to this particular application. I'm going to commit this directly to the master branch, so not following any best practices here. So we'll commit that change, and immediately you will see things start to happen. As Kubernetes grabs that change, as GitOps grabs that change, starts to orchestrate the creation of new containers and pods, and starts to decommission those that are now no longer accurate based on the new version that's been pushed to the Git repo.
Thanks, Matt. It's great to see how easy it is to deploy and manage your applications with Arc-enabled GitOps in AKS on Azure Stack HCI. So now that we've deployed an application, what comes next? Well, deployment is half the battle. Now we need to make sure that our workloads are doing what we want them to do. And that brings us to our next topic, container insights. Let's go over to Austin, who will walk us through what that means in AKS on Azure Stack HCI.
Thank you, Jessica, for the introduction. Now that we've covered what AKS on Azure Stack HCI is, you might be wondering, how can I monitor my cluster? Our native solution is Azure Monitor Container Insights. Container Insights provides you with the tools you need to make sure your cluster stays healthy and your applications are up and running. Container Insights collects key infrastructure metrics on your CPU, memory, disk, and network. We provide chart and grid visualizations so that you can understand when your resource bottlenecks might be a constraint. We also provide a high-level management view so that you can track your cluster health across all your environments and Azure subscriptions. And if you want additional customizations, we provide these through our integrations with Azure Dashboard and Azure Monitor Workbooks so that you can choose what information you want to keep track of. We provide drill-ins to associate your metrics with your container logs so that when you see any warnings or failures, you can quickly investigate those issues. Lastly, we have out-of-the-box alerting, where you can quickly configure alerts on key health and performance signals with a single click. You can choose the way you want to get notified through email, text, or phone, and even set up auto mitigation through Logic Apps and Azure Functions. Now, we'll move on to our demo portion, where we'll discuss some scenarios around logging and alerting with Container Insights. Now we can use Container Insights to troubleshoot this application. Navigating to the Containers tab, we can see the full list of our containers. We can search for the Hello Arc application, and selecting it provides us a property panel with additional information. Clicking in on the View and Log Analytics button allows us to explore the container logs. As you can see, Container Insights collects the standard error and standard out logs for you to analyze. This is super useful if you notice any issues with your deployments and need to investigate. You can also modify this query to add more granularity and help with your investigations. One of the most important parts about observability is being proactive through alerting, making sure you're immediately aware and can take action to resolve any problems. And so one of the great features about Container Insights is the recommended alerting experience. Configuring alerts can be tricky and time-consuming since you need to track down various metric namespaces and decide on thresholds. This is where recommended alerts come in. By templatizing metric-based alert rules, you can turn on these alerts with a single click of a button. Once they're on, you can select a designated action group to decide on what kind of notification you want to do. We have various options, including email, triggering webhooks, as well as SMS and voice notifications. Once they're on, you can also decide if you want to make changes by clicking on the alert and making adjustments accordingly.
Now that we've seen how to deploy an application with Arc-enabled Kubernetes and how to use Container Insights, let's take a look at a few key customers who we're working with directly to help them adopt AKS on Azure Stack HCI. Let's begin with Commvault, a large data protection and management software company. They're using AKS on Azure Stack HCI in production, running on a 2-node switchless data-on integrated system for Azure Stack HCI. They're planning to add more Azure Stack HCI clusters in the next few weeks to enable other departments to also use AKS on Azure Stack HCI as their development and production platform. 1-800-Contacts is the world's largest contact lens retailer that provides a hassle-free way to replace your contacts. They're evaluating AKS on Azure Stack HCI as a way to potentially host some of our services in their existing data center infrastructure. They're actively engaged with us, and leveraging AKS on Azure Stack HCI with their application workloads has been a success in their staging DevOps environment, which is identical to their production environment. Next, we're working with bwin, an online entertainment provider who has over 45,000 servers around the globe. AKS on Azure Stack HCI simplifies the process of setting up, maintaining, and securely operating on-premise Kubernetes clusters. It enables them to operate Kubernetes clusters that are integrated into existing infrastructure to bring the benefits of cloud-native workloads running on-prem. Lastly, Vertical Aerospace, a British aerospace manufacturer, is looking for a containerized solution to run on-premises to support critical applications required for the operations of their aircraft. They're currently evaluating AKS on Azure Stack HCI, Azure Stack HCI, and Azure Arc-enabled data services among the list of Microsoft technologies. Since our GA release in May, we've been listening to the user feedback and still working on incorporating it to make AKS on Azure Stack HCI your go-to source for all your hybrid Kubernetes needs. We've had a number of exciting features ship, a few of which I'll spotlight now. One of the features that we shipped since GA is node pools. A node pool is a group of nodes in the same cluster that are grouped together by the same configuration. This improves the way that you deploy and manage your clusters. We have introduced new PowerShell commands that enable you to create, scale, and delete at the node pool level, giving you more granular control over your clusters. You can deploy multiple Linux and Windows node pools in the same cluster that have different VM sizes. Because different workloads need different resources, the variation in VM sizes and OS types let you make sure that your heavy workloads get the resources it needs without wasting resources on lighter workloads. You can easily do this by applying a taint to a specific node pool and then add a toleration to your app deployment YAML file. In doing so, that node pool will only run the applications that have that toleration. These are some more features that we've shipped since GA. We brought in Calico CNI integration because we saw that most customers who use some sort of Kubernetes technology want to use network policies out of box, and they're accustomed to using Calico in the cloud, no matter which cloud they're using, because it's the default in most cloud and on-prem deployment these days. Next, we've moved to Containerd as our container runtime. Containerd brings you a container runtime that is simple and robust. Lastly, another important thing we heard from customers is improving reliability and high availability. So we introduced automatic distribution of virtual machine data across multiple clusters' shared volumes, which makes clusters more resilient to shared storage outages. In the past, virtual machine data was saved on a single volume in the system. If that volume failed for whatever reason, the whole cluster would be unavailable. Now, the virtual machine data is automatically distributed across all available CSVs in the cluster, enabling higher availability and reliability for your applications. AKS on Azure Stack HCI releases new builds on a monthly cadence, so you won't have to wait too long for new features and improvements. To get these improvements in your AKS on Azure Stack HCI environment, we recommend that you always upgrade to the latest build. Let's go over to Matt, who will show us how this is done.
Thanks, Jessica. Now, before we dive into looking at what an upgrade of an AKS HCI infrastructure looks like, it's important to understand what some of the reasons are as to why you'd want to stay as current as possible within your AKS HCI environment. And firstly, and hopefully obviously, the way to get the new latest and greatest features and capabilities for both AKS HCI and the Kubernetes infrastructure it deploys and manages is to take these updates and upgrade to the latest versions. But in addition to that, it also addresses any bugs or issues that have been discovered in the product during the lifecycle, and more importantly, from a security standpoint, ensures that any critical vulnerabilities that have been discovered are addressed, ensuring the highest levels of security in the product. And finally, from a supportability perspective, we want to encourage customers to stay as close to current as possible to retain that fully supported experience running AKS HCI for their important workloads. But what does the process look like? Well, fortunately, it's very simple. Somebody, a user, an administrator in the environment who has permission to manage the AKS HCI environment, initiates the upgrade, and that will start the rolling upgrade of the management cluster here on the left with the number 2. So what does the upgrade process actually look like for the management cluster? Well, I've highlighted the key steps here on this slide with PowerShell as the focus. Now, you can also upgrade through Windows Admin Center, and it's really straightforward, just a couple of clicks and it will handle it for you. But in terms of PowerShell, firstly, make sure you've got the latest modules. So update your module, your PowerShell AKS HCI module, and then run the command get AKS HCI version. And that's going to tell you which AKS HCI version you're running, not specifically the Kubernetes version, but the AKS HCI version. And then once you've got that information, check to see if there are any updates available for you. So run get AKS HCI updates, and that's going to return hopefully a list, or at least just one new version that you can upgrade to. Obviously, if you're up to date, it's going to return nothing. But in my case, what you can see on the slide here is I've let things lapse a little bit too much. So I'm actually running a couple of versions ago. So I'm encroaching on an unsupported territory here, and I want to make sure that the upgrade process is going to handle getting me to the most current version that's available. And thankfully, that's exactly what happens. So when we run update AKS HCI, it's going to move us through those different versions one by one, upgrading, automating the entire process. And each time it goes through an update, it will download all the necessary bits, it will orchestrate the process, it will create a new management cluster VM on your Azure Stack HCI environment. It will stand up and integrate that with the existing one that's already there, transfer resources, synchronize everything, wait till everything settles down, and then decommission the old one. And so in my case, it's going to work through that process a number of times to get me up to the latest release, which at this time is 1.0.4.10.928. So that's going to bring me up to date in a fully supported position. Now with the management cluster upgraded, and hopefully you agree it was a very straightforward process, we can move on to number 3 here on the slide, which on the graphic on the right hand side is our workload cluster, our target cluster if you prefer. And initiating the upgrade of the target cluster is going to upgrade the Kubernetes version for that particular cluster and update the OS if necessary. And what that's going to do is introduce new features and capabilities for that particular Kubernetes version. And it's going to perform a rolling upgrade of all of the VMs in this environment, load balancer, control planes, and worker nodes, whilst ensuring uptime for your application and workload. So let's take a look at what that looks like. Now, before we upgrade our target cluster, let's just explain what we've got on the screen here. So on the left-hand side, similar to what we saw earlier, we've got our PowerShell ISE, where we're going to be running the upgrade commands from. In the top right, we've got our web app, which we don't want to be impacted by any upgrade operation. And in the bottom right this time, I've got my PowerShell window where I'm going to monitor the pods that are powering our application and the status of those throughout the upgrade. So as you can see at the moment, we can see we've got a number of pods powering this application that are all important to stay running in order for this application to operate. So the first thing we're going to do is going to get the versions of Kubernetes that were available to us to upgrade to. And I know that this particular cluster is running version 1.20.5, but you can see that we can run up to 1.21.2, which is quite a few releases ahead. So that's the one I'm actually going to choose. But let's just check what I've got available to me for my particular cluster. And you can see I've got the option between applying an operating system upgrade or some differing levels of patch or minor Kubernetes upgrades from the Kubernetes perspective specifically. I'm just going to take the single command of update AKS HCI cluster, define the version that I'd like to upgrade to, and let AKS HCI take care of everything for me, including any OS upgrades that might apply as part of that. So I'm going to let it handle that whole process by clicking yes to all, and off it goes. So it starts similar to what we saw before, downloading the necessary images, ensuring they're in the correct location, the cloud gallery, etc. And from there, we're going to download the new image for the Kubernetes version that I desired for this particular release. Let's open Hyper-V Manager. And you'll see, similar to what we saw before with the management cluster, what's going to happen to certain VMs as we perform this rolling upgrade of the infrastructure. And so what you'll see very quickly is as the process gets a little bit further on, we're adding images to the cloud gallery now, things have been extracted, and you'll see very quickly that virtual machines are now starting to be created in the environment as this rolling upgrade begins. So in this case, the first load balancer VM is being created side by side with the existing load balancer that was there previously. And once that's up and running, if we scroll down in the Hyper-V Manager here, you'll see we've now got 4 control planes. 3 was the number we had earlier, so 1 additional one has just started. Again, as we roll through in a rolling upgrade manner, keeping your application, keeping the control planes redundant and resilient as we upgrade the overall target cluster, which, as a reminder, has the load balancer, the worker nodes, and the control planes all to upgrade. And so you'll see now we're running an extra worker node side by side with our existing worker nodes as we again roll through and transition those respective resources onto the new VMs that are being deployed as part of the upgrade. And it's important to note when from a capacity standpoint that you do have enough capacity within your environment to handle these additional VMs starting up and running the different components of the infrastructure. And now let's flip over to look at the pods, and what you'll see on the pod side is that more and more of these actions are happening. We're creating new containers, we're terminating existing pods. These are a reflection of our application being provisioned on the new nodes that are running in the environment. So we've accelerated this a little bit just to streamline the process, but you'll see very quickly over a number of moments that the container infrastructure, AKS HCI, is orchestrating that creation and curation of all of those new applications and workloads. And so before long, we've got our environment up and running without any downtime, and our application has stayed redundant, stayed available. We can check if we've got any more updates that are available for us. Nope, we're on the latest version, so nothing for us to do. And what you notice there, the node OS has also been upgraded as part of the deployment. So straightforward, very easy to deploy and manage the upgrade and update process of a target cluster.
We've also added more capabilities to Windows Admin Center since GA. We've been monitoring our deployment telemetry and addressed common deployment errors that customers run into. We've made significant efforts to better the experience and make it more robust and optimized so that our users will be able to benefit from these constant improvements that's gone into the deployment workflow. On the feature set, the deployment workflow will now include support for node pools, max pod count, and taint support. You can deploy multiple Linux and Windows node pools in the same cluster that have different VM sizes. Windows Admin Center will now support provisioning node pools by easily applying a taint specific to the node pool and defining a max pod to that node pool. This way, you have better control on how resources are utilized by the Kubernetes clusters based on the workloads that run on these clusters. Another common ask that we've heard from customers is to allow proxy settings provisioning as part of WAC's deployment workflow. With the latest extension in Windows Admin Center, you can deploy your cluster with proxy settings that have both basic authentication and trusted certificate mechanisms. Lastly, we now have a single-click upgrade experience in Windows Admin Center that would allow users to update both AKS management cluster and workload clusters. You no longer need to switch between PowerShell and Windows Admin Center to manage your clusters. All your cluster lifecycle management operations can be achieved within Windows Admin Center. Now you know all about AKS on Azure Stack HCI and how we're continuing to improve it based on your customer feedback. So what now? Well, I hope that if you've made it this far in the session, you'll try out AKS on Azure Stack HCI yourself. Here are some helpful links again that will get you up and running in no time. I'm excited to see how you use AKS on Azure Stack HCI and looking forward to hearing all the feedback so we can make it even better for you. Thanks for sticking with me this far, and thank you all for your time.